This is the fourth video on Unit 6, and this is talking about primarily talking about when given a graph of sine and cosine, find both the sine and cosine function that represents that graph. And so I wanted to, instead of working with kind of a blank screen here, I'm working with section 6.3 because I have a couple graphs on here I want to go through. But before getting there, let's just talk about some things that we discussed before getting into looking at these graphs. And that was looking at sine, cosine, and tangent and seeing whether they were even, odd, or neither functions. And we primarily looked actually both at their graphs for looking for symmetry, but also looking at definition of even and odd to figure that out as well. So let's just recall the definitions of even and odd. So a function is even. Let's go back here. A function is even if when I plug in negative x, then I get the same output as the plugging in the positive counterpart. That would result in y-axis symmetry. That's an even function. And an odd function is when I plug in negative x, it would be the opposite sign of the output when I plug in the opposite sign of an input. And that has origin symmetry. So when looking at the sine function, it's good to have in your mind how sine function y equals sine of x normally looks. Normally, sine would start, if we look at right at the origin, it starts on that midline and goes up to its highest value. So it looks like this, the sine function, and that has origin symmetry, which would suggest this is an odd function, which means when I put in a negative angle, it's negative sine of putting in that positive angle. And that makes sense if we think about the coordinate, if we think about the quadrants. So for example, say we had theta being some quadrant 1 angle. If I think of then negative theta, well, that would be a quadrant 4 angle, and yes, the sine in quadrant 1 of that angle would be positive, but in quadrant 4 it would be negative. They'd have the same absolute value ratio, but if I think of drawing a triangle here, this would be y and r, which is the definition of sine, but this would be negative y and r here. Okay, so sine is an odd function. Well, if we think about cosine, let's first think about what the graph of cosine looks like. Cosine of x starts at its highest value, if we talk about along the y-axis, and then goes down on either. Sorry about that. So it starts at its highest value on the y-axis and then goes down, and the same on the other side. You can see this y-axis symmetry, and which suggests an even function. So f of negative x equals f of x. And so then when I think about going back to thinking about looking at the quadrants, just like we did before, if I think I've got this positive acute angle in quadrant 1, and then comparing that to negative theta. Well, remember, in both quadrant 1 and 4, cosine is positive, so they would have the exact same ratio. Same would be true if I started with like a quadrant 2 angle and comparing that to the negative, which would be in quadrant 3. Well, in quadrant 2 and quadrant 3, cosine is negative. So the ratio would be the same, and they both would be negative in that case. So cosine is an even function, and we said sine was an odd function. And what about tangent? Well, tangent At this point, we haven't done the graph of tangent, so let's just think about the quadrants. If I think about, let's take a quadrant 1 acute angle. And remember, tangent is y over x, and both are positive there. But if we compare that to negative theta, x is exactly the same here, but the y value will be negative. So this means that tangent of negative theta is negative tangent of theta. So tangent also is odd. And once we get to seeing that graph, you'll see that it does have origin symmetry, much like sine has origin symmetry. Okay, so now let's, so from there we can talk about the negative angle identities, which are just what we did before, that sine of negative theta equals negative sine theta. Cosine of negative theta equals negative cosine theta, and tangent negative theta equals negative tangent theta, and the reciprocal functions follow suit as well. So you could do that for cosecant, secant, and cotangent. Okay, so now I want to get to looking at a graph and finding an equation that describes that graph, both in terms of sine and cosine. So let's skip ahead to, I want to do one of the more meaty ones. Let's look at number 5. And whoops. All right, here we go. All right, so a few things we need. So the first thing that seems pretty easy to get from here is the fact that I have the highest y value is 5 and the lowest y value is -3. So I can find the amplitude and vertical shift using that. So the amplitude is going to be 5 minus -3, so the max minus the min value divided by 2. So the amplitude is 4. And so remember, the amplitude is how high and low the curve goes from the midline. So I can use this to find my new midline, which will tell me my vertical shift. And so if I go 4 away from 5, that gets me at 1. So my vertical shift will be up 1. And again, that dotted line is my new midline here. Okay, so I've got the amplitude, I've got my vertical shift. Next up is I want to get the period of the function, and I've given you a high value and a low value here. And in terms of how far, going from a high value or a peak to the low value, the next low value or the consecutive low value, which is also known as the trough, well, that is going to be half a period, because a full period here would be going back up to the peak. So I know from 19 pi over 36 minus 7 pi over 36, that's a half a period. So a half a period is going to be this distance. So let's find out what it is. That's 12 pi over 36 or pi over 3. So that was half a period. That means that the period is going to be 2 pi over 3. And now let's figure out, remember to find, when we had an equation, then we were graphing it, to find the period, we would do, the period was equal to 2 pi over b, but now since we're trying to find the equation, we want to find what that b value is. What's that coefficient of x? And so if I solve for b here, it's going to be 2 pi over the period. So I can use the period I just found to find the b value. So 2 pi divided by 2 pi over 3 is going to be 3. Okay, so almost there. So here's what I've got. I've got an amplitude, vertical shift. I've got that b value. Now I just need the phase shift, because I'm noticing that along the y-axis, I'm not starting right on the midline, and I'm not starting at a higher, lower point. So both the sine and cosine are going to have phase shifts. Now, given I have this point here, which is a high point, I think I'm going to start by doing a cosine function. Now, and it would be a cosine graph without a phase shift. The cosine graph would start at its highest point. So the phase shift, in order to match the graph I have, is shifting to the right, 7 pi over 36. So let's put that into equation. We've got y equals, I've got my vertical shift was up 1, and I'm going to have positive in front of the amplitude because with cosine I'm starting at the highest point, which would mean I'll have a positive in front of the amplitude. Cosine, and then the b value is 3, and I'm going to put that outside these parentheses here because I'm talking about a phase shift after the period's been changed, so it's going to be to the right 7 pi over 36. And you certainly can leave it like that, but if you prefer to distribute the 3, you can say 1 plus 4 cosine 3x minus 7 pi over 12. Now, there's a few ways I can find sine now. One of them is, well, given I have the period, I can find the interval width, meaning what's the distance between those critical angles I plot. So the angles that when I plug them in for x, I'm really evaluating the trig function at the quadrantal angles. So what did we say the period was? 2 pi over 3. So the interval width is 2 pi over 3 divided by 4, or 2 pi over 3 times a fourth, which will be pi over 6. Okay, so if that's the case, I actually can find this point right here by just doing taking 7 pi over 36 and subtracting pi over 6. So 7 pi over 36 minus pi over 6, or minus 6 pi over 36, is just going to be pi over 36. So I'm going to say pi over 36. Okay, so why would I do that? Well, I would do that because now I have the phase shift for a sine graph. So I could say y equals 1 plus 4. I'm doing plus again because if I'm starting on the midline and going up, there's a positive in front of the sine function, in front of the amplitude rather. 1 plus 4 sine, again 3, but this time the shift is to the right, pi over 36. And I could, again, distribute that 3 inside the sine function, so 4 sine 3x minus pi over 12. So say you didn't want to do that, or say it was hard to find that one of the angles on the midline, I could go back to this cosine function that I have here, this right here. And another thing, we know the relationship between sine and cosine is that cosine of theta equals sine of 90 minus theta, or pi over 2 minus theta if we're talking about radians. So I could use that to, from this 1 plus 4 cosine 3x minus 7 pi over 2, get the sine function. I could say 1 plus 4 sine, and then do pi over 2 minus this angle that I was taking the cosine of. So this gets me 1 plus 4 sine. Distributing the negative and combining like terms, I get negative 3x plus 13 pi over 12. But you never want to report a trig function with a negative b value, so we want to then deal with that. Let's factor out a negative inside the sine. So 1 plus 4 sine negative 3x minus 13 pi over 12. And why is this helpful? Well, we know from our negative angle identity that sine of negative an angle is negative sine the angle. So I could just, I could just write 1 minus 4 sine 3x minus 13 pi over 12. So that's another way you could get a function, that's another way you could get an equation that's describing this graph of the other trig function. You could use that co-function relationship between sine and cosine. Okay, let me see, should we do, all right, so that's, we'll do more, name that graph in a bit, but I want to turn to, let's turn to number 10 in here, which is solving and giving all answers. Okay, so this is number 10 here, as I just said. So remember for part A here, sine squared x just means sine of x squared equals 1. So to solve for something squared, you're taking the square root of both sides, but plus or minus. So thinking about where sine is positive or negative 1. Well, it's first, if I'm thinking of starting at 0 and going around the circle, it's 1 at pi over 2, and then it's negative 1 at 3 pi over 2. It'd be back up to 1 at 5 pi over 2, and then 7 pi over 2, and so on. It would be negative 1. Well, how could I express all answers here? Because, of course, every time I hit... in other words, if I think about going out around the circle, every time I hit the y-axis, I'm not going to hit either positive or negative 1. Well, I can express that by saying, notice that all these angles are pi away from each other. So I'm going to say that the solutions can be expressed as x equals pi over 2 plus k pi. And I'm going to say where k is an integer. And the symbol for that is k is contained in the set of integers. That's the symbol for that. All right, so now let's think about, so that was when it was landing on an axis. Now let's think about something, one of our special angles. So cosine of x equals negative 1/2. Cosine is negative in quadrant 2 and quadrant 3. So the quadrant 2 angle, if I think between 0 and 2 pi, that gives me negative 1/2 would be 2 pi over 3. So I'm going to say x equals 2 pi over 3. And when will it hit that angle again? Well, remember the period of cosine is 2 pi. So every time, if I could think about, every period, or I think about every time I go around the circle and hit that particular angle in quadrant 2. So I'm going to say plus 2k pi. And in quadrant 3, I'm going to do the same, 4 pi over 3 plus 2k pi. And again, where k is contained in the set of integers. Well, the nice thing about cosine is, remember, it is positive in quadrants 1 and 4, and negative in quadrant 2 and 3. So I actually, instead of writing two separate angles plus 2k pi, I could just write it as x equals plus or minus 2 pi over 3. So write it in one statement, because negative 2 pi over 3 is coterminal to 4 pi over 3. So I could say plus or minus 2 pi over 3 plus 2k pi. Again, it's fine if you want to do two separate statements, but I think it's helpful to recognize the fact that you can write that in one statement, just plus or minus 2k pi. Okay, so I think we're going to stop there.